Hello engineers, welcome back. In this video, we're going to practice the concept of hash maps using a Leet code question. I hope you're ready. Let's get started. So this is the question we'll look at today. It's called two sum. This is a famous problem. Let's try to understand the question and then we'll see how we can use hash maps to improve our solution, right? Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. Okay, let's take an example and try to understand this. So the array is 2, 7, 11, 15, target is 9. So the array is 2, 7, 11, 15 and target is 9. So the idea is find two numbers so that they when we do x plus y, we get 9. Okay, and we need to return the index of x and index of y. So how can we do this? So the brute force method is to pick up the first element and compare it with all the other elements. So 2 will be compared with 7, 2 will be compared with 11, 2 will be compared with 15 and so on. And if there is a target found, we return the index, otherwise we move on to the next element and repeat it again. So 7 will be compared with 2 again, 7 will be compared with 11, 7 will be compared with 15. So this is the brute force method. As you know, this can involve a nested loop and it is in the order of n square. So this is not acceptable. This is not efficient, right? So there has to be a better solution. So we can use the concept of hash maps for this. So here is what we'll do. So we have 2, 7, 11, 5, right? So imagine we have a hash map like this, where the key will be array element, and value will be index of the array element. Index of, for example, key will be array element is 2 and the index of it is 0. This is 0 indexed array, right? 0, 1, 2, 3. And 7 will have the index 1, 11 will have the index 2, 15 will have the index 3. So if this is my hash map, can I use this to iterate over this list in O of n time and find my answer? So let's see how we can do this. So let's say my hash map is empty for now. It's empty and I'm iterating through this list 2, 7, 11, 15. Now when I'm iterating through this, I reach the number 2. What do I need to reach the target? I need some variable x to reach the target, right? So this x has to be within this array, right? It has to be within the array. Now, if I already have a map with all the elements in the array, I can use that to check for x. So what will be x in this case? X equal to 9 minus 2, which is 7, right? I can use this x to check in my hash map. So is 7 present in my hash map? Is 7 present here? If it is present, I have found my answer. I know the index of the current element. I know the index of the number which will add up to the target, and I know two indices I can return. So when I'm at 2, I need to find 7. At this point of time, my hash map is empty, so there is no 7. So I will add the current element to this. So I will add 2, 0 to this hash map and move on. Now my index is here at 7. At 7, what do I need? 7 plus x equal to 9. I need something to reach the target. So x is 9 minus 2, it's equal to 7. 9 minus 7, sorry. 9 minus 7 equal to 2. So I can check in the hash map. Is 2 present in the hash map? Yes, 2 is present in the hash map. And I know the index of 2. So I found my answer. I know the index of 7, which is 1. Now I know the index of the number which will take me to the target, which is 0. So I have the answer 0, 1 and I can return it. Okay. So let's take another example so that it is more clear. Let's say 3 to 4 and target is 6. So the array is 3 to 4 and target is 6. So my hash map is empty right now. I am at the first element. The first element, there is nothing to compare. So hash map is empty. So I will just add 3 with the index 0. Second time when I'm here at 2, I need to find what is the number that will get me to the target. So 2 plus x will give me 6. So x is 6 minus 2, that is 4. So I need 4 to reach my target. So is 4 present in the hash map? No. So I will add this element 2 with the index 1. Okay, and I move on. Now I'm at 4. What do I need to reach my target? I need 4 plus x equal to 6. X equals 6 minus 4, that is 2. Now I'm checking in the hash map. Is 2 present in the hash map? Yes, 2 is present in the hash map. So I know the answer now. What is the index of 4? The index of 4 is 2 and the index of 2 is 1. So I can return 2, 1 or I can return 1, 2. It doesn't matter. I have found my indexes. Okay, so that will be our solution. This way we are able to iterate over the array only once in the order of n, but we are consuming additional space because we are using hash map. Okay, but that's okay. We have optimized very much from O of n square to O of n. Okay, so let's see how we can build this. So first we need to return a vector of 2 numbers. So we will create that answer first, which will be of size 2. And then we will use our map. In our unordered map, both the key and value are of type integer. So let's just call it map. So now we can iterate over the array. So for int I equal to 0, I less than nums dot size I plus plus. Now at each step, what did we say? We need to find this number. What is the number x that will get me to my target? So let's say my x is nums of a, which is my current element, plus, not plus, I need to do target minus nums of I, right? So what is the formula for x? X is target minus current element. 9 minus 2, 9 minus 7. So target minus current element. So x. Next, I am checking if x is available in the hash map. If map dot find x. Okay. So find is a method part of the unordered map. It will tell us if the element is available in the map or not. Okay, if the key is available in the map or not. So we can do like this for clear understanding. So auto it equal to map dot find, and we can pass in x. Okay, and what this returns is it returns an iterator, and iterator will be equal to map dot end if the key is not available, or it will be a pointer to the key value pair. So it's like this. So if it not equal to map dot end, which means my key exists in the hash map. If it exists, then I have found my answer, right? So I can do answer of 0 equal to map of x. I need to get the index, and then my second index will be the current I. Now I'm at I here, and that will be in my, that is my second index. And once I find my answer, I can break. I don't need to do anything else. But if the element is not found, I can add this key to the hash map. So how do I add it? I say map of nums of I. Nums of I is having the current array element and the value will be index. Okay. So quick recap, what are we doing here? First, we are iterating through the array and we are finding x. X is the value that I need to reach my target. Once I have that, I am checking if that value is available in the map. If it is not available, I'm adding the current element to the map. But if it is available, I have found my answer. I'm just adding it to the answer and I will break. And I can simply return answer. Okay, let's run and see. So our solution is accepted. Right. So this is a practice to show you how to use hash maps to reduce the time complexity and improve our solution, right? So imagine if this was a brute force method, we would have to use nested loops and keep comparing every element with each other, and that is not very efficient. Okay, so that way hash maps can help us for doing quick lookups. Okay. So that's it for this video, guys. If you have any questions, definitely ask me. Don't forget to leave a like and subscribe to the channel. I will see you in the next one. Thank you. Cheers.